Hi, in this topic we are going to talk about generator in Python. Python provides a generator to create your own iterator function. A generator is a special type of function which does not return a single value. Instead, it returns an iterator object with a sequence of values. In a generator function, a yield statement is used rather than the return statement. The following is a simple generator function in this graph. So in the normal function that use the return keyword, but in the generator function that we use the yield statement and return a generator object, and the generator start the execution when the next keyword or function is called. So let's take an example here. It is more memory efficient than the iterator. So let's give an example. So here, so I call a function that is my generator, and inside the function that is called print my first item. And as I told you that in the generator function that we use the yield statement function, that I initialize my generator function to the gen variable. Then again, whenever I call the generator function, then I have to use the next keyword or next function to iterable of this function. So whenever I call this, I run this, then again I run next generator. It will give me the first value with the first item, right? 10. The and again if I run, it will give me the second value. That is second item, that is 20. And if I run the second, it will give me third value. And if I again run this, then it will give me an error because there is no values there after the last value. That is giving a stop iteration error. All right. So I can handle this error via try and accept condition. We can use the for loop to traverse the element over the generator. In this case, the next function is called implicitly, and the stop iteration is also automatically taken care of it. So in this example, so I create a for loop that is for I in the range and 1 and 2, and 1 is my start point, n is my stop point, and 2 is my step point. And again I use the else statement. So for that, so I have to use to initialize my function. So I can write to iterator. So most have to give an iterator for I in, this is my generator function. So let me write it, and my n should be, let's say my n is 5, let's say 10. If let's say print I, so let me run it. Will give me the output 127, 125, 343, 729, because the it will give me the range between 1 to 10, and that will be between 1 and 2 is my step, right? So the n is my 10, and that will be my range function count for n minus 1 up to 9. So first will be 1, and 1, that is cube, equal is my 1. 1 into 1 into 1, that will be 1. And next is step 2, that is mean 1, then it will come after the, that will be 2 step, that will be the number will be count at 3, and 3 into 3 into 3, so that will be here 27. And next will be count, that's 5 into 5 into 5, that is 125. Again 7 into 7 into 7, that will be 343. And then will be last number will be 9, and 9 into 9 into 9, that will be 729. So here this is our generator function is called. So next thing is we can handle this uh, here, that is usually square. So I can handle this using the try and accept condition. So if let's run it, it is giving me up to 16. So let's say my range is 5, and it will give me the up to the 4. So the range will be 0, 1, 2, 3, 4. And first in the 0 case, 0 into 0, so it will be 0. In the 1 case, that will be 1 into 1, that will be 1. In the 2 case, that 2 into 2, that will be 4. And 3 case, that 3 into 3, 9. In 4 case, 4 into 4, it will be 16. So again I can handle the except condition here. If that stop iteration is occurs, it will break the statement, so it will be not giving any error. So this is the example of generator in Python. So as I told you that the advantage of the generator is over the iterator is that elements are generated dynamically. Since the next item is generated only after the first is consumed, so it is more memory efficient than iterator. So in the next session we are going to talk about the more advanced topic of the generator.